So welcome, my name is Terrence Barkin. I'm the Executive Director of the Graphene Council, and together with the Graphene Engineering Innovation Center at the University of Manchester in the UK, we are hosting today's webinar, and the topic is how to achieve net zero targets without sacrificing performance. There are going to be two presentations. One is led by James Baker, the CEO of Graphene at Manchester, and so he'll start his presentation here in just a second. And then I will follow with a short presentation from the Graphene Council. And then we're going to engage in dialogue and discussion about the topics that we're presenting. And we encourage you to post your questions using the chat feature or the Q&A box. And with that, we'll get started. So I'm going to stop sharing this screen. And James, if you want to pull up your presentation, we'll start with that. And thank you. Really appreciate the chance to host this together with you today.
Thanks, Terence, and good morning, everyone from the UK. So thanks for that introduction, Terence. So I'm James Baker from the University of Manchester in the UK. And today's subject, whilst we're tightening around opportunities for graphene, 2D materials, advanced materials, I think what I'd really like to get across is how this can support some of the challenges we have around sustainability, or as we say in the UK, the drive towards net zero. I think Terence will touch on later, but increasingly across the globe today, we're seeing the impact of climate change and how there is a lot of emphasis around moving towards a more sustainable economy, a more sustainable future for the various countries we live in. I think the message, though, I want to get across, and for me, it's a theme of a lot of what we're trying to do with Manchester and graphene and 2D materials, is as well as looking at new materials and the technology involved in that, we also need to look at the business model in terms of how we approach new materials. And we probably have to do things in a much more rapid way than we have traditionally done in the past in terms of the adoption of new materials and manufacturing. And again, just to give a bit of context, my background is aerospace. Certainly talk around more electric aircraft by 2035, flying across the Atlantic with zero carbon emissions. As a view, I think if we're going to achieve that, and we work traditionally, we should have probably started this journey 10, 20 years ago. So really, as a message from today is, first of all, what is the opportunity of new materials? Secondly, we probably need to do things differently and start sooner rather than later. But I think the key takeaway I want to try and get from the presentation is that sustainability doesn't mean you have to do something with a compromise. So often when we think about sustainable, we think about it's going to be more costly, it's going to be lower performance. But certainly from the case study I'm going to talk around today, we can achieve something that's more sustainable, but it's also lower cost, higher performance, and has other benefits or improvements as well. And I think if we're going to drive things commercially, sustainability might be the drive that enables us to do some change, but can we do things that create value, create commercial value, as well as societal benefit in terms of net zero? So just first of all, just a little bit of context. I'm here in the University of Manchester. Many of you, I'm sure, have now heard of graphene or aware of graphene. It all started 2004, sticky tape and a pencil with a graphite, peel that many times to isolate a single atomic layer of carbon. 2010, the Nobel Prize for Physics. But for me, what's really exciting being involved in graphene and 2D materials, in the 17 years since that discovery of graphene in the lab in Manchester, we're now really starting to see a real increase in engagement from industry, from all sectors around graphene products and applications. And for me, I often use the term of third wave of industrial engagement. The first wave of industrial engagement was the pioneers, the leading edges, the companies who did that first engagement. The second wave for me was 3-4 years ago, where people started to engage in graphene. Some of those have now got products on the market. And today, for those who are aware, you can buy graphene shoes, graphene tires, anti-corrosion paints, graphene in polymers, graphene in cars, just to name a few. So already we're starting to see graphene playing a role in a number of components. But part of the drive towards what I call the third wave is also being driven by the need for sustainability. And I'm going to pick on a particular sector around construction, where drives towards targets on sustainability are now creating the catalyst for engagement with industry, but there's still that need to create value, to generate profit, to generate products that are commercially viable. So following the Nobel Prize for Physics in 2010, in Manchester, we created the National Graphene Institute, very much around the science of 2D materials. And today, alongside the Sir Henry Royce Institute in Manchester, there is a huge amount of great research around not only 2D materials, but around in the future, these layers of materials or heterostructures to build functionality into your product or your application. But as well as the science, I talked about the business model. For me, we also needed to develop a much more rapid, a much more innovative way of innovation between academia and industry in the creation of supply chain. But how do we turn the innovation cycle that traditionally takes months and years into one that can be measured in days or weeks? And our response to that in Manchester was through the creation of the Graphene Engineering Innovation Centre in partnership with Mazda out of Abu Dhabi, but with UK and European funding. We created the GEEK. And the GEEK is very much around that translation of the science into products and applications through the so-called Valley of Death. And those who have seen my presentations in the past will have seen me talk around the Manchester model, where on the x-axis we talk around TRL or technology readiness level, and on the y-axis we talk about system readiness level. And the journey, if you like, from bottom left of this chart through to top right, from the science through to products and application. And there's a general scheme how universities typically operate bottom left. The National Graphene Institute has started to push that along the TRL, but address things like standards, toxicology, yield, process, etc. The GEEK is around the Valley of Death, but for me, it's about that engagement model between academia, supply chain, and industry that's absolutely key. A key part of this chart is sort of in the middle, along the right, around what we call technology capability demonstration programs. And one of the things I want to get across today is, as well as the science and as well as the need for testing, for validation, for doing the engineering activity, there's a real role to play of producing large-scale demonstrators that sit alongside some of the development of product to become, if you like, a living test lab. So in my background of BA Systems, which is a defense aerospace company, it often involved designing, for example, a small drone or an unmanned vehicle that we could use as a platform for testing new technologies. Why on an unmanned vehicle? Without a pilot, we reduce the risk, but it's enabled you to get real data from a flight of sensors, of materials, of propulsion systems in a real-time environment that can reduce the risk from taking that technology from the bottom right of this graph into the top right of products and applications. So again, as a real sort of case study, I would like to give you an example where we can create living labs that create data that reduce risk, that accelerate our product into the marketplace. So what I really want to focus this presentation on is just one case study around construction. When we look about the drive to sustainability, we could look at aerospace in terms of lightweighting, in terms of alternative propulsion, in terms of multifunctionality. So can we get the wing of my aircraft as well as being structurally strong? Could we also do de-icing, lightning strike protection, as well as energy storage? So there are many case studies of graphene and 2D materials that could play into aerospace, could play into automotive, could play into the energy market, new forms of batteries, supercapacitors. But I'm going to really focus a little bit around construction, and in particular around an opportunity around concrete. But this could be around bitumen or asphalt for roads. It could be around anti-corrosion properties to extend the life of crash barriers or of steel structures, through to smart infrastructure of the future or smart highways as we go forward. So one of the partnerships I'd like to talk about is a partnership we have in Manchester with an organisation called Nationwide Engineering. Nationwide Engineering, the relationship started 2 years ago. It was a conversation between myself and some of the founders of Nationwide, two ex-alumni from the University of Manchester, around the challenges or drives they were seeing in their marketplace, both around innovation, but more importantly, around the need to address sustainability. If concrete was a nation, you would see that the emission of CO2 is more than most states. I think 10% of the world's emissions on CO2 are linked into concrete and concrete production manufacture. So if we could reduce the amount of concrete, that would have a significant impact on the reduction in CO2 and the drive towards sustainability. So we started off with a vision of a stronger, cheaper, greener concrete. And this is a brief summary of some of the activity that we've undertaken with these partners nationwide over the last 6 to 12 months. I won't play it now, but in the handout or in the read-around, there's a video. If you haven't seen it, you can click on this link and actually watch the video, which will give you a little bit more on some of the real pictures around some of the work that we've done to date. But I won't play it now, but please look at that or look on YouTube and look at Concretine and you'll be able to play that video in your own time. So what is a partnership? For me, it's a partnership between academia and an industrial partner. Nationwide Engineering are a construction company. They're people at the real front end of construction. They're involved in construction from buildings to industrial to rail. And at the University of Manchester in the Geek, we have the facility, the capability to both produce, to measure different graphene products and applications, from composites to batteries, to coatings, to inks, through to being able to integrate those into a subsystem or a system for evaluation and development, but very much about a partnership working with industry. So from day one, Nationwide brought a challenge of greener, more sustainable, but they also brought a challenge as they had to do something that was fit for purpose for the construction industry. Not something that took place in a laboratory in a university, but something that concrete, for anyone who's been involved in it, are people in old weathers, in concrete mixers, pouring concrete. It has to set, it has to finish, it has to be producible, and it has to be something that's practical to be able to use to actually produce and to actually use afterwards. So that for me was quite key from the day one. This was very much around a partnership and a collaboration. But what we've been able to do, and this has been evidenced if you watch the video, we've now completed 3 separate graphene pours. And when I talk about a pour, we're not talking about a small area. We've now poured over several hundred tons of concrete on 3 different pours. We've done a gymnasium in the UK near Stonehenge in the UK, for those who are familiar. We've also done a housing estate. And then 2 weeks ago, we actually did a stretch of road or a lay-by outside the Graphene Engineering Innovation Centre in Manchester. And we've got other concrete pours being planned over the coming weeks and months. And what we've been able to demonstrate through these pours is not just the science, but this is where the headline comes from. Sustainability, if you're going to reduce carbon dioxide, one of the best ways of doing that is eliminating the need for concrete or some of the concrete. So to date on the pours we've done, we've been reducing 30% of the concrete content. So that's immediately a 30% reduction. Again, that's just for the first pours. We're actually getting feedback from those pours. Depending on the application, we could actually maybe reduce even further amounts of concrete in the future. We're also, though, reducing the need for steel in some of those floors. So on some of the pours, we've actually managed to do this without any steel rebar. So again, that's a further reduction in cost. It's a reduction in CO2. It's a reduction in labour. And it's also a reduction in terms of some of the time it takes to lay a traditional concrete floor. So overall, we're actually seeing a cost reduction despite adding a further additive. So there is a cost of adding some of the graphene, but with the reduction of material, manpower, and steel, for example, we're seeing on average a 20% reduction in overall cost. And that's before we see some of the other benefits from using concrete, in that we're seeing increase in cure time, we're seeing increase in the actual tensile strength. And as you'll see on the bottom here, we're still adding a very, very small amount of graphene in a process that is actually very reproducible, because we actually do this in the batching plant and not in a laboratory in a university. And that's the other key part of this activity, is there is no new training, there is no new equipment, there is no new staff or activity required. The graphene mix is added as an additive into the batching plant. It turns up in a cement mixer and you pour it in the traditional way that you've always produced cement. So for me, there are some real benefits and improvements for what we're doing through these various pours, as well as getting real data. We have a living lab, so the lab outside the Geek that we poured 2 weeks ago, we're doing measurements every day, every week, over the next period. And to just give you an example of some of the fringe benefits, we actually achieved greater than the design performance of 28 days within 12 hours of the initial pour. Now, if we can translate that into something practical, it means now you don't need as long on site to lay your concrete, and you can actually continue with your follow-on operations in a much shorter time. So when you look at the broader sustainability agenda, it's not just a reduction in concrete, it's a reduction in lorries to the site, it's a reduction in footprint, it's a reduction in the overall time and risk that's taking place on a building site. So that translates into further benefits that we're still evaluating, we're costing, and we're taking further understanding. So as a simple statement, what you can see through the work we're doing on what we call concretine with Nationwide Engineering is improvements on strength, durability, and tensile. But we're also seeing some other benefits that if we can optimize, again, we haven't done the work on this yet, but there's real opportunity. There could be work around porosity. We've seen so far very few cracks, which has got a benefit for certain applications, and also improvement around things like permeability, where again, when you look at sustainability, there are products on the marketplace, but they're not always the most environmentally sustainable products in the future. Key one for me, though, is a reduction in CO2, and we're still doing the calculations, but already we're seeing significant reduction opportunities, both real and potential, for applying 2D materials into construction in the future. And it's not just concrete, it's everything from concrete to coatings to structures going forward in the future. And again, key to this partnership is our work with Nationwide, but we're working with the broader University of Manchester, as well as funders from UK Innovate and the European Union, who have supported the various programs that we're running today. I've talked a lot about concrete as a case study. I could have equally talked over case studies around automotive or aerospace and lightweighting. I could have talked around recycling. And again, there's great examples of rubber mats, for example, where we're taking recycled rubber crumb, and through the addition of graphene, we can get a recycled product that is reusable without the performance challenges that you normally get from using recycled rubber crumb. And again, just to quote one stat, one of our partners there has done a rubber mat that's 1/3 thinner than a traditional recycled rubber mat, but it's 5 times more durable. So again, that translates into potential lower cost if you engineer that, longer life, and at the end of life, you can chop it up and reuse it and recycle it again. So again, the through life cost and recyclability increasingly becoming a drive when we look at some of these products in the future. And through the addition of 2D materials, we seem to be able to use recycled materials without the traditional compromise of a loss of performance. And again, that's an area of great interest that we're working with a number of partners. So that's the end of my presentation. For me, we like to use this term Graphene City. For me, graphene is in a very exciting stage. Sustainability is really driving a lot of the dialogue we're having with industrial partners today. It's a catalyst that enables the engagement. But for me, if we can deliver solutions at lower cost, at higher performance, both in terms of manufacturing costs, but also through life costs and performance, then immediately that becomes very attractive for industry to engage. And if we can continue this journey, I think we're at a very exciting stage. But if we're going to meet the targets around sustainability, we can't afford to hesitate. We need to continue. We need to move. And with that, let me pass on to Terence and look forward to answer any questions you may have later. Thank you, Terence.
Well, thank you, James. It's an excellent presentation, and it certainly highlights all the reasons why we're having this discussion today. And so what I want to do is augment that a little bit with a slightly different perspective. Today's presentation is going to be a little bit different than what we've done in the past. It's going to be less technical and talk about these drivers for adoption. For those of you who are not familiar with the Graphene Council, we are a neutral global trade and professional body for the graphene sector, representing every segment from academia through to end users and everything in between, connecting more than 30,000 material scientists, 2/3 from commerce, 1/3 from academia. And you can think of us as a nexus or connection point. If you're looking for developing graphene solutions, then we have the ecosystem. And this gives you a representation of some of our members within the Graphene Council. And you see there that we have, as I said, research institutes, academia, government research institutes, graphene producers, intermediary companies that are experts at manipulating graphene, and end user companies in a really wide range of application areas. So if you're not yet a member of the Graphene Council, of course, we encourage you to consider that. So what is the major problem that we're trying to address with today's conversation? Well, it's crystal clear that ever since the end of the Second World War, from about 1950 until today, there has been a dramatic increase in CO2 emissions. And whether you believe that CO2 man-made emissions are affecting the environment or not, the truth is right now that governments, the populace in general, and businesses have all decided that decarbonization of the economy and all of the impacts on reducing CO2 emissions is where we are headed. I think that's an important distinction to make. And just to give you evidence of this, this is a list of companies that have set net zero targets. So the response to the dramatic increase in CO2 emissions and climate crises and the changes for our environment has been companies declaring that they wish to be net neutral on CO2 emissions, most of which are between 2030 and by 2050 at the latest. So that means less than a decade from today until within the very near foreseeable future. An enormous number of companies have made these declarations. The challenge now is, how do we actually get there? How do we get to this net zero target from where we are today? And today's materials, which have been maximized and optimized to about as far as they can go, are not going to get us to net zero. What we need and what we see happening is this revolution in advanced 2D materials. They're called advanced materials because they have substantially improved performance characteristics compared to legacy materials. There are phenomena that happen at the atomic level that make these materials, including graphene, which is pure carbon, behave in ways that the macro form of these materials do not behave, and they can enhance the performance of other materials, making them stronger, lighter, more electrically conductive, better sensors, better heat transfer properties, and many, many other attributes. And so this new class of materials is important not just to improve what we're doing today. And the example with concrete is a fantastic example. Here we take a material that's been around literally for centuries and get it to perform at a level that we haven't been able to, despite many decades of intense R&D and optimization of a concrete and cement materials. Graphene comes along, and at less than 0.1%, at 0.0000% by weight, we get dramatic improvements. That's an example of the capability of these new engineered nanomaterials. So the message here is simply this: if we really are serious about getting to net zero in our economy, business, and in our environment, legacy materials will not get us there. We need to use new advanced materials that have substantially improved performance to help advance towards that goal. That's what we're talking about today. So what is the role that graphene has to play in this? So I'll give you just a couple of examples, and there's a lot of really good science behind this and real life demonstration, but I just want to give a high-level overview of what we're talking about. Adding graphene to a material making it more durable and longer lasting, will emit less CO2 simply because we're not putting it into a waste stream, we're not incinerating it, or you're not replacing it as frequently. That's one example. The CO2 reduction for reducing cement content in concrete is a really good example, but there's also asphalt. So bitumen and asphalt for roadways, making them last longer so they don't have to be repaired as often and making it more durable, or the ability to simply use less material to achieve the same objective, all helps us to reduce that CO2 footprint. The recyclability of materials. So for example, I'm going to call out a couple of our companies, but we have dozens and dozens of companies that are capable to help with these solutions. But for example, NanoExplore, one of our companies that produces graphene, has demonstrated the ability to add graphene to plastics that were at such a degraded point that they weren't able to be recycled as is. But by adding graphene and improving the performance of that recycled material, you could divert material from a waste stream into a recycled product, extending the life and again, reducing the CO2 imprint from that material. Graphene from biomass is another way of producing graphene. So the exciting thing with graphene material, because it's a pure carbon material, there are multiple ways of making it. Typically from graphite, which is exfoliated into the nanoparticles, but it can also be made from other carbon sources. And almost every day we hear about another way of making graphene, including from renewable sources or diverting, for example, waste gases like methane or methane and converting them not only into graphene, but also separating hydrogen, which is important for a zero emission economy. That's another example. To go further, electric vehicles and the electrification of the transportation system is a positive step, but it comes with another trade-off, and that is that existing tires and rubber technology is not suited to deal with the heavier weight of these vehicles. They're therefore increasing the wear on the tires. And so what do we need? We need tires that can maintain the grip and the traction that we need for safety, but also can wear longer. And graphene, again, at a very small percentage added to these elastomers, can improve the performance of tires, making them longer lasting without having to sacrifice traction. Another example is in heat transfer, and I'll call out another company, GMG, which has demonstrated adding a graphene coating to existing air conditioning units, improving the heat transfer properties, making them much more efficient, means less energy is used because we're going to continue to use air conditioning in our built environments. And so it's really important that we have a reduction in the energy needed to continue to treat that air. Another example is using graphene membranes for water treatment, whether it be for wastewater treatment or for desalination. Membranes that, because they're so much thinner, require less energy to treat that water, whether it's desalination or for waste treatment, which means less energy use and also less biofouling, which means that they last longer without having to be replaced, and that reduces the downtime for those facilities for management. And another really important area with the electrification of the transportation network, as well as the move to sustainable energy through wind and solar power, requires large energy storage capacity. So for example, for energy generation from wind, solar, or hydro, that energy needs to be stored so it can be used when it's needed. Often that's not the same time when it's generated. That requires massive energy storage and a new generation of batteries, as well as for electrification of transportation like EVs. And so whatever sector you might happen to be in, and we have representation in our audience, we know, from many, many different sectors, chances are extremely good that graphene has applicability for your sector to not only reduce the CO2 footprint, but as James really well laid out in his presentation, that we can actually improve performance at the same time. And because so little of graphene is needed to have these massive improvements, it also, even if it's viewed as a quote unquote expensive material, you really have to look at what is the total value of improving the performance, reducing CO2 emissions, having better performing and longer lasting materials, then the trade-off for cost, often it's an advantage. It's not, it doesn't necessarily mean that it has to be more expensive. I do want to point out that we have a close partnership and relationship with the University of Manchester and the Graphene Engineering Innovation Center, and that there's a special partnership available for Graphene Council member organizations to access the resources at this facility under special member-only conditions through the Graphene Council. And what does that mean? The facilities are quite impressive for rapid prototyping, and that's what we're really talking about today, is going from considering graphene and thinking about it and maybe looking at it theoretically and actually getting this now into products, because it is proven to work in many of these applications. We have quite a number of companies that have scaled production, and we are going to need, for example, just in the cement application, if graphene is used in 0.1% of all of the concrete used on the planet on a yearly basis, that translates into over 100,000 metric tons of graphene required, even at that very low loading factor. And what's important for end users to know is that there are a number of really good quality graphene companies that have ramped their production facilities and are anticipating the demand that we know will come. It's just a matter of when. And we think that time is now. And the facility at the University of Manchester and at the GEEC is there to help to do rapid prototyping and application testing of the materials. And this also includes access to the National Graphene Institute, as well as the Henry Royce Institute for Advanced Materials, which means the network of facilities that are available and the equipment that's available to do the prototyping and testing extends throughout the United Kingdom, again, in partnership with the Graphene Council, if you choose to go that route. And as a last bit of information for our audience, again, for those who are maybe not as familiar with the Graphene Council as some of our members are, the Graphene Council does provide specialist advisory services to help you take a product from concept through to completion and to develop products, putting you in partnership with qualified graphene producers and application development partners. We also are the authors of the most comprehensive and extensive report on graphene, from production methods and processes to commercial forms of the material, market pricing data, application, standardization, and many other aspects, including profiling the most commercially mature companies. And that's the Graphene report, which is available to our organizational members, or it could be acquired directly. And so with that, I just wanted to highlight that we feel, James and I both, in the graphene community, is that many things have advanced, especially in the last few years. And if companies are serious about reaching net zero targets, it is crystal clear that new techniques and especially new materials will be needed to obtain those goals. And we think that graphene, amongst other 2D and advanced materials, is ready today because of production capacity, quality, and consistency, demonstrated applicability. It's now just up to adoption. And with that, I'm going to stop sharing my screen. James and I are going to take some of your questions, and we're going to have a discussion about this. Let's see what kind of questions have come in. James, I don't know if you've had a chance to look at those, but do you see any questions that you want to tackle right away?
There's a couple of questions. I mean, as always, we get questions around, what is the carbon dioxide footprint of graphene? And one of the challenges we have, first of all, is there are many different forms of graphene. I think what's very interesting, I'll put it around the trend around what's going on. As very simple statement, we can produce graphene by what we call top-down method. So that's typically taking graphite and breaking it down into graphene by many different forms. And depending on the manufacturing production process, they have different levels of carbon footprint, from very energy intensive to much more environmentally friendly. We can also produce it bottom up. Again, typically, but not exclusively, that's around CVD graphene or synthetic processes. And again, there's a variety of carbon footprints associated with that. Also in the chat, though, quite interestingly, and it's certainly a trend that we're seeing, is a move towards what I'd call more of a bio-produced graphene. So again, whether that is recycled So again, there is an interesting company in the UK who take methane from bio-waste and create graphene, through to, for example, taking waste biochar or carbon dioxide or methanol, alcohol, and breaking that down into graphitic type material. Again, for those of you in the US, you may have seen a process called flash graphene out of Rice University, who take waste plastics and convert that into graphene. So what is the carbon dioxide CO2 footprint of graphene? It very much depends on the source, on the manufacturing process, but certainly as a trend, I see a move towards more environmentally friendly processes of producing graphene. Again, it depends on the application, it depends on the market, but I think as a trend, going back to Terence's point, if we are going to move towards net zero, and again, just answering another question, net zero is a systems level problem. Not one single thing is going to achieve net zero. To achieve net zero, it's going to be a combination of things, from the way we grow food, through to the way we travel, through to the way we build our buildings. So it's a systems approach to achieving net zero. No one single golden bullet is going to get there. And I think we've all got a key role to play, whether we're in aerospace, whether we're in automotive, whether it's the way we have our own personal buying patterns or travel. All of that will contribute towards that net zero target. And I think for me, what I'm trying to get across on the example of concrete, that contributes towards it. If we can reduce the CO, if we can reduce the concrete, that immediately has an impact on CO2, because there'll be less concrete being used around the world. Great if we could reduce concrete altogether. So we also need to look at alternative materials. We need to look at recycled materials, which I touched on. So for me, they're all going to contribute towards that. So I think you'll be careful around, trying to answer around one specific area. The approach we're trying to do on concrete, if you look at the global demand, there's some great studies around there. If you saw from my presentation, we're not adding a huge amount of graphene, but if we're going to actually put graphene cement or graphene concrete in every construction around the world, we need to look at these new forms as well as existing forms, just for the supply to be able to meet that demand. There is actually a need to look at these alternative methods of producing graphene going forward. Just on volume alone, no one supplier or one source can meet all of those demands. And that's a key point I think we all need to be aware of.
Well, Jay, I think you hit some really good points with that. And there are a couple of questions here I'd like to tackle and kind of tack on to what you just shared with us. So one of the questions is, the sustainability of graphene production, graphite mining versus, bio and other kind of renewable sources. And then there's another question about the price of graphene. And of course, the prices for graphene have been all over the map, from as little as $50 for a kilogram to as much as $50,000 for a kilogram. And the other thing that we didn't really touch on, that we've talked about many times before, is that graphene, from a commercial perspective, should be thought of as a family of materials, not just one single standardized material. There's many different iterations and types of graphene, including a graphene oxide, reduced graphene oxide, single layer 3, 5, 10, et cetera, functionalized, et cetera. So there are literally hundreds of forms of graphene. And so I want to try to address three of these topics together in one. Regarding the cost, the fact that so little graphene is typically used in the end application, it can sustain a relatively high cost and still make economic sense to use graphene because of all of the other benefits that are achieved. And while today's presentation is focused on achieving net zero targets and how graphene and other advanced materials can reduce the CO2 footprint, I think something should not be lost in what James had said about the cure rate, where a cement project or a concrete lay that normally would take 28 days to cure achieve the same parameters in a 12-hour period. And so with graphene, if we can reduce CO2, that's great. But if it doesn't also make economic and business sense, it's not going to be adopted or not adopted widely. And we've seen time and time again that graphene offers multiple benefits, many of which are not the target of using graphene, but they're add-on tangential benefits. And the accelerated cure rate for concrete and cement is one of those, where it allows an engineering company to get offsite, or as James said, move to the next stage of construction without having the project sit there, which means better utilization of capital, equipment, and staff. Now, in terms of sustainability, graphite as a resource is mined and used widely for a wide variety of applications. It's not as if we're creating new graphite mines specifically for graphene, and relative to the amount of volume that graphite is used in traditional products like brakes or as electrodes, or it's used across many different industries, the diversion for graphene is not great. And when you combine that with the fact that you're also using a relatively small amount of it, the CO2 footprint itself for graphene is going to be relatively insignificant, especially compared to the savings that it's able to put into the end use application. And because the volumes that we are going to need, and the Graphene Council has forecast within the next 3 to 5 years, demand of between 300 to 700,000 metric tons of graphene, we are going to need every source of production, whether it be from biomass or it be from graphite, to be able to produce the volume that will be needed for the market. And the last thing I want to say that's important for industry is we've seen with rare metals and rare elements that there can be supply constraints. There can be 1 or 2 countries that have the majority of supply, and that puts the rest of the supply chain at risk. Graphite and graphene is widely available, and graphene will continue to be widely available so that no one country or region will be able to monopolize it. And it also means it can be produced close to the source, close to the end use, which means we also don't have issues of transportation and adding to CO2 emissions, which is true for some other materials that often get transported long distances. So those are just some additional points that I wanted to point out that I think augment some of the things that James had said and what we're trying to get across with our presentation, and address some of the questions you all have around CO2 footprint and cost and sustainability of this material. So James, did you find another question that you want to address?
Yeah, I'm trying to answer a few questions in one. There's clearly a number of engineers in here who want to answer what I call good, proper engineering questions. And I started off my presentation by saying if you work traditionally, we probably do 20 years of development of testing to understand the full cycle cost, the cure times, the end of life. So there are a lot of questions that we still haven't got full answers for. And what we're doing as an example though on concrete is the standard work. So we're making test samples, we're putting those samples through various testing at 1 day, 7 day, 14 day, 28 day, checking tensile strength, other measurements. So there's a lot of traditional testing that you can take place that if you do that traditionally will take you years, if not even tens of years before you get to market. I think what we're trying to show, and the slide I used earlier in terms of a living lab, is whilst we're doing all of that, we've got a partnership with Nationwide Engineering, which is effectively undertaking technology demonstration programs, as I presented, or test pours. And what I mean by that is there is some risk involved. And when we poured the slab outside the geek, we didn't know whether the concrete would come in one lump or a stream, or whether it would pour, whether it would work. There was still some risk involved in undertaking that. As a positive, we're now undertaking free pours. We are doing testing. We're getting data as we talk. As an example, the pour 2 weeks ago, the cure time after 12 hours was 225% of the design life after 28 days. Now, you could argue that's over-engineered because that's too strong. But what that's telling us is we could probably make it even thinner again to reduce even more concrete, or we could reduce the amount of graphene inside. So this living test lab is all about gathering data, gathering information, which we can then put into our various models, into our various business cases to understand the benefit. What we're not doing, and I think this is quite prudent, we're not building a block of flats or a bridge, or I was asked the other day, why don't we do the dome of a palace? That for me is probably too high risk, but the floor of a gym, the floor of a lay-by, a housing estate. Next week, we're going to do, next few weeks, we're going to do what I call a fairly structural application. Again, I won't go into too much detail. It's a managed risk. So what I'm really calling for is there's a role really for the supply chain industry to take that managed risk. And again, it's taken very careful. We need to address the testing, we need to address toxicology, we need to address handling. Going back to when I said zero staff, one of the approaches we had with the concrete, a design aim from day one that we had to achieve is that the graphene needs to be added in a batching plant under a controlled environment. So this isn't someone tipping a bucket of graphene powder into cement. This is effectively an additive that is added alongside other additives in a batching plant. And that's important both for occupational health and safety, but it's also important because it's an industrial scalable process. So I think we've got to approach these in a very, what I call, engineered manufacturing way, but we've got to get some of that data on an ongoing basis. So in the UK now, we're going through various forms of certification, registration. We're working with partners like NPL, National Physical Laboratory. As I mentioned earlier, we've got some funding through Innovate UK, which has enabled us to do some of that testing. And we're also working with our partners nationwide to see how we can accelerate that whole rate of testing and activity going forward. So lots of activity on concrete, and we're not alone. I know there's a number of people on this call who are also looking about graphene in cement, graphene in concrete. So across the world, there's a broad area of activity. Some of the questions are being asked are proprietary. So what graphene, how do you mix it? How do you do that? Part of that is the know-how that we work with our industrial partners to create, because we want to create competitive advantage. So it's important that we understand not just how we take the graphene, but how we mix that graphene in an industrial scalable process that we can take to market in a rapid way. So I'm answering about 4 or 5 questions in there. Time frame is dependent on the application. We're on our 3rd, what I call engineered pour already, and there'll be more to follow. And there are other people around the world who are doing similar or slightly different activities around graphene in cement. And it's an area that's moving very quick. But as Terence said, we could have talked today about batteries or composites or coatings. Again, a number of areas where we're seeing some real rapid progress. And I think sustainability is a catalyst, but at the end of the day, you still need to demonstrate performance and cost improvements if you're going to take this forward commercially.
Absolutely, James. And I appreciate that last comment is, we do focus a lot on concrete, which is extremely exciting because it is such a large CO2 emitter. But there are examples in composites, thermosets, plastics, coatings, et cetera, as you've said. Some of the other questions are related not necessarily to net zero, but to some of the other potential barriers to adoption of this material. And that has to do with standardization, and it has to do with the regulatory side. And that's an area where the Graphene Council, together with our Graphene Industry Strategy Advisory Board, are addressing issues around health and safety, for example. So recently, we compiled a resource of all toxicological related reports related to graphene. Compared to other materials, the toxicological profile for graphene, especially since it's pure carbon, is rather benign, but that's an area that we continue to work on. The Graphene Council engages directly with the FDA and EPA in the United States, for example, on filings. We've had companies just recently, NanoExplore and the General Graphene Group, both have received approvals from EPA under the TSCA regime. We have a collection of companies in Europe that are part of what's called a REACH consortia, which have filed regulatory filings for the sale and distribution of graphene in Europe. And so these regulatory hurdles are being addressed. One of the other areas that the Graphene Council is working on with a panel of close to 100 volunteers is a graphene classification framework. This is an approach and a definition of different forms and types of graphene that will be beneficial to regulatory agencies who we've engaged with, as well as standards bodies, including ISO, IEC, BSI, ASTM, and other standards making bodies, so that we can get standards for graphene material so that it can then be specified in engineering applications. All of this work is ongoing, and this is part of what the Graphene Council brings to the table, and another reason why we really want to work together with the full ecosystem, from graphene producers to end users and everyone in between. So we engage with regulatory agencies on both the health and safety as well as the standardization and the classification side, because that's what the industry needs. And again, the time is now. We've gotten past the incubation stage. We're really at the stage where it's ready for adoption. And I would invite companies that really want to be innovators and those that want to achieve net zero goals to engage with us and ask about how we can apply this unique and novel material to your engineering and your product development challenges. And the added benefit is not just the CO2 reduction and the net zero targets, but the fact that you can also differentiate your company from your competitors by having a product that performs at a higher level. And the other thing, as a shout out for ourselves as the Graphene Council, we do run a verified graphene producer program, a verified graphene products program. And we also work with institutions like the GEEK in the UK, like the NPL in the UK, and like other leading laboratories for testing and validation. We are a completely independent, neutral third party representing the industry, and we can help connect you. And also, if you have materials that you need evaluated, tested, and analyzed, we can facilitate that for you as well. Our whole mission, as well as that of the GEEK, and I would say, I think, I've said it before, I want to applaud the University of Manchester, because I think the institution is really setting an example of what a university can do. By doing the Graphene Engineering Innovation Center, you've developed a prototyping center that doesn't exist, and it allows companies to use facilities and personnel and expertise that they would never be able to use in-house to develop these products. So working together, our combined mission is to enable the adoption of graphene and advanced materials on a large industrial commercial scale, not just because it makes good business sense, but it makes really good sense for the environment and for sustainability. And I'm happy to take some more questions here, James. I don't know if we want to answer something else, but we're getting close to the top of the hour, so maybe we should get close to kind of wrapping up today's session. This isn't the last time we're going to talk to our audience. Anybody can reach out to us and ask questions at any time. This will be posted on our YouTube channel, so it'll be available publicly. Did you have some additional questions or topics we want to hit?
No, I mean, thank you for those words. I think for me, if I could sort of summarize for me, I mean, there's a lot of questions there about what graphene or what graphite, and process. So for me, turn that on its head a little bit is we need a problem we need to solve, and we need an engineering solution that's repeatable, affordable, and practical to delivering a solution. And for me, moving away from what I call bottom-up thinking, outside-in thinking is what problem we're trying to solve. And again, credit to Nationwide, or an organization who came to us with, they saw a clear drive. This was several years ago around sustainability. It was probably before some of the commitments and targets. So Terence put up a load of targets. A lot of those have been agreed and signed up over the last 12 months. And certainly I've seen an increase in some of the larger companies who are now taking an interest in graphene because they've got to achieve targets. We have one of our customers who has said, and this is, again, a little bit careful with my words here, but it said there's only so many trees we can keep planting when we build a new building or a structure. And yes, you can start to move towards carbon zero by offsetting your carbon credits by planting trees or planting forests, etc. So that's important. That contributes towards the global situation. I say it's a system problem, but there's only so many trees and forests we can plant. So for me, we have got to start exploring new materials, new ways of producing aircraft, cars, batteries, our buildings, our roads of the future. So for me, it's about actually achieving an effect. But if we can achieve that at lower cost and higher performance, a sort of example for me of graphene, and we're still learning, is a number of people have started along the graphene journey around a particular area, but it's some of the byproducts that are increasingly important. If I just take the rebar and the steel, as soon as you can say you can achieve a structural flaw without steel or rebar, not only do you get the performance, the cost benefits, the CO2 reduction, it changes the way we think and the way we do our construction going forward. So a program we're about to do shortly, if we'd done that traditionally, the site would have been taken up for a whole week of a crew of people putting in rebar, connecting that rebar up. We now don't have to do that. So in planning this concrete build, we now have to allocate a day in the build schedule. If you can then move on to that a day afterwards, because it cures quickly, it changes the whole cycle of the way we do construction and we do builds. So it's not just the CO2 of the floor, it's the broader environment. Anyone who's in the UK at the moment knows there's a shortage of lorry drivers. For the build outside the Geek, traditionally would have needed 3 loads, we only used 2. It's a minor contribution, but at the moment, if we can have 1 less wagon on the road carrying concrete and hopefully carrying food to the supermarket, again, it can improve the national situation. Now, that's a bit local around what's happening today, but for me, it's the broader understanding of the value of advanced materials and the benefits it might provide for a sector like construction. So again, it's sort of encouragement for you all, not only just to look at graphene, but to really understand how it might start to translate or transform your particular sector or your particular product market that you work in. So happy to answer any other questions if there are, as Terence said. But yeah, thank you for listening, and appreciate it. If there's anyone got any questions, happy to follow those up.
Well, James, listen, thank you for that presentation. I think what you've enunciated there is really powerful. If you think about how did we get into the situation we're in today, it didn't happen overnight. It started back in the 1950s, and through different sources and addition of carbon to the environment from many, many different places, we got to the point where we're at this unsustainable level of man-made CO2 emissions. And how we're going to reverse it isn't going to happen overnight, but it's going to be all hands on deck. In every place we can save a little bit, whatever application it might be, whether it's taking 1 truck off the road or reducing the content in the built environment, or whether it's in coatings and materials that last longer. That's exactly how we're going to attack this problem. And the unique thing with graphene is that it has so much applicability. It's not a one-trick pony. It's not like it's only good for one application. It's good for at least 45 to 50 major vertical markets that we've identified so far. And so whatever your industry, whatever your application, if you're interested in understanding this material, then please do get in touch with us so that we can connect you with the right resources. And there is one last point I want to make, because a lot of the questions and comments are, how much does it cost? Can I get my hands on this? The challenge with graphene, we have to always still remember, it is carbon, but it's engineered at the atomic level. It's not something you can just take a bucket of and chuck it into a matrix and it'll work. It takes expertise and it takes knowledge to tune the right graphene for your application. You should think of it more as like a specialty chemical than just a commoditized material. So it takes real expertise to know what type of graphene needs to be engineered for your specific application, how to disperse it, how to functionalize it if that's needed, and that takes knowledge and expertise which has been accumulated over the past decade. And that's the kind of resources that the Graphene Council can put you in contact with. That's the kind of resource, knowledge, and skill that's embodied at the Geek. And we can guide you. It's not, this isn't something, don't try this at home, right? You need some guidance, you need some expertise to get the results, because unfortunately people have tried graphene in the past without that knowledge, expertise, or understanding of the nuance, have not gotten the results, and have said graphene doesn't work. But that's not the case. Graphene works, but it works when you use the right material with the right type of application, the right dosing, and the right guidance. And that's why we're here today, is to offer our expertise and guidance to help you along that journey so we can all get to net zero. And with that, I think we'll close today. James, thank you. I always appreciate talking to you. I always learn something whenever we do these things together. I hope this was beneficial for our audience. And it is really exciting to be doing something that has such a great potential impact positively for our world. So thanks for joining us today.
Thanks, Terence. Thanks, everyone.
All right. Be safe out there. Take care.
Thank you.